Dear students, welcome to another video for Operation Research course. Now we will move to the most important topic, which is transportation model. Transportation model is a special case of a linear programming model, where we have linear programming that have only two values, x1 and x2, that we are mentioned before in chapter 2. Here we have to deal with two shipping of a commodity from source, that are factories, to destinations, that are warehouses. So we have only two variables, then we have a linear programming. This means that a linear transportation model is a special class of linear programming that deal with the shipping of commodity from a source to a destination. The object of the transportation model is to determine the shipping schedule that minimize the total shipping costs. That's why we say that a special class of linear program that deal with a minimization problems only, not a maximization problems, because we want all the time to minimize the cost of shipping from the source to destination. The model assumes that the shipping cost is proportional to the number of the units shipped from a given route. In general, the transportation model can be extended to another areas of operations, like the inventory control, employment scheduling, personal assignments, that all have the minimization category, not maximization. So we want to give basic samples for the transportation model, that we have a CIJ. CIJ means that unit cost of transportation from the source I to destination J. And we have XIJ. That means the quantity to be transported from source I to destination J. All the time, we will have two main points. Source I, this is the source, and destination J. So in our model, we want to ship all the values from I to J with a minimum cost. They are quantities, like a factory that wanted to get the products to the warehouses and ship these products from the factory to warehouses, but with minimum cost. The objective of the transportation model is to determine the unknown Xij, the quantity that will minimize the total transportation cost, and at the same time satisfy the supply and demand requirements. Should satisfy the demand and supply requirements. The solution of the transportation model in this case will be divided into two parts. The first part is determining the basic starting solution, and we will use three different methods, or introduce in this chapter three different methods to get the starting solution for any linear transportation model. We have three methods that are north-west corner method, least cost method, and finally Vogel approximation method. This is all have a starting basic solution, but we want the optimum solution. In our models and our problems in operation research course, we always seek to get the optimum solution, not the starting solution, not the visible solution. So in the first step, we will get the starting solution by any of these three methods. But this is not the end of the problem. We should reach the optimum solution, and we will get the optimum solution in the second step by using the methods of multiplier. Please concentrate on this topic, because we will have today on this video the northwest corner method and the least cost method. We will introduce the three starting basic solutions for transportation model by an example to introduce the three methods and difference between the three methods. The transportation algorithm for the three methods follows the exact steps that simplex method that we have in chapter 3. However, instead of using the regular simplex tableau with iterations that may be so many times iteration for the same problem, we will take the advantage of a special case of the transportation model and the easier algorithm to organize the computation in a more convenient form. So we will begin introducing a transportation model and getting the starting solution by using the northwest corner method and least cost method and vocal approximation method by this example. Now we have an example. Sun Ray Transport Company ships truckloads of grain from silos to 4 mills. The supply and demand, together with the unit transportation model costs per truckload on the different routes, are summarized in the transportation model in the following table. Note here, please, we have a source I and destination J. The source with the factory and destination J, which is the mill. Here is the cell that we want to transport to 4 mills. And we have supply amounts and demand amounts. Here, the transportation model is always a balanced model. The supply amount equal to demand amount. And we have number of I, row, and J columns. And the values inside these rows and columns is the cost of shipping from source to destination. So these values is the cost. Introduce our cost. Cost 1. This means the cost of shipping from source I to destination J, from source 1 to destination 1. And this is cost 1, 2. This means it is a $2 the cost for shipping from the destination I or the destination 1 to the source for the cost for shipping from source 1 to destination 2. And 20 equals the cost C1, 3, the cost of shipping from the source 1 to destination J. And this is, for example, C3, 3, the cost of shipping from source I or source 3 to destination 3. This, for example, cost 3, 4. This means the cost 18 is the cost for shipping from source 3 to destination 4, and so on. Again, the values inside the table is mentioned for the cost, and the values for the demand and supply mentioned Xij, which is the quantity that should be shipped. The quantity should be shipped. So we have here the values. Again, another. So beginning to answer this example and use the northwest corner method to get the starting solution, we already type again the cost for each transporting from source I to destination J and put the demand and supply for quantity in this form. Then we will begin using the starting solution by northwest corner method. From the name of the method, it starts with the northwest corner. I mean the northwest cell. So we will start with this cell and with this value for cost. We will start here and put the values for demand here that intersected with this cell, that demand equal to 5 and supply equal to 15. We will take the less quantity plus quantity is equal to 5. So we take 5 from demand, so this will be 0. In this case, the demand will be 0, and 15 minus 5 equal to 10. So the supply here equal to 10. Now this destination is become 0, and we can't take any more from it because we have 0 value here. So we can't move to downward. We should move here in this cell. Okay, this cell is intersected between the value 10 for the supply and value 15 for demand. Value 15 for demand and 10 for supply. We will take the least value, the number 10, because it's the least value. So we'll take 10 here in the cell, and the supply in this case will equal to 0, and subtracting 10 from 15, the demand will be 5. Here, this source will be closed because we haven't any more amount to be shipped, and the quantity here is equal to 0. In this case, we should go to the cell that is downward, and we will move to this cell with the cost 7. And when we have standing on this cell, we get the intersection of the demand and supply in the cell that equal to demand equal 5 and supply equal to 25. Again, we will take the least value. So we will take here 5, and take 5 from 5 in the demand will equal to 0, and 25 will equal to 20. Here, this destination is closed and the quantity shipped is equal to 0, and we haven't any more quantities to be shipped. But we have here a value in the supply in this row. So we can move to this cell with the cost 9. And this cell is intersected with demand 15 and supply 20. So we will take a value 15. Here, subtracting 15 from 15 demand to be 0. And here, subtracting 20 from 15 equal to 5. And now this destination is also closed because we have any more amount to be shipped, and we will go to this cell because the cell is open and we have 5 amounts for shipping in this row. So this cell that is the intersection between the 15 quantity and 5 quantity, we will take the least one, which is equal to 5. Here we will put 5 to be the value 0 and 15 to be the value 1. Now we have only one cell that's equal cost for this cell equal to 18. We will go to the cell and put the value, and because it's the balanced model for transportation model, we here have 10 and 10 for the supply and demand quantities. Here 10, we take 10 to be this demand value equal to 0, and 10 and demand value equal to 0. And this is the starting solution. Be careful, the starting solution by using northwest corner method, don't pass diagonal. We can't move from this cell, for example, to this cell. We should pass horizontal or vertical. We can't ever pass diagonal. And we can't go backward. We can't go backward from here to here, for example. No, we only go forward. We only go forward. So be careful. We're starting with the northwest corner method, or northwest corner cell, and we go horizontal line or vertical line. We can't go diagonal lines, and we go forward. We can't move backward. And we go to the cells that only have a quantity to be shipped from a supply or a demand. Now, please, let's erase all these values and get the values that we have to take. Now, in our solution, we have the values. Here was 5, and in the cell was 10, and in the cell was 5, 5, and in the cell equal to 15, and here 5, and finally this was 10. This was the solution that we are already get in the previous table. Now, if you count the basic cells, or what is meant by the cells that have values inside, we find that 1, 2, 3, 4, 5, 6. We have 6 basic cells. We have 6 basic cells. This value coming from that number of rows, m, for sources, plus number of columns for destinations minus 1 should equal to the total number of basic cells. We have 3 rows and 4 columns minus 1, which is equal to 6. So our solution is true because we have only 6 basic cells for this problem, because the number of rows, which is m, plus number of columns, which is n, minus 1 should equal to the number of basic cells. Why there are basics? Because they have values inside each cell. So we call these cells basic cells. They are basic cells. Now let's do the final step for the starting solution, which is calculating the starting basic solution. How to calculate the starting basic solution? How to calculate the starting cost for transporting this amount? The starting cost can be calculated by multiplying each cost Cij by the quantity which is associated in this cell. This means that Z for the starting solution will equal to 5 times 10. 5 times 10 plus 2, 10 times 2. 10 times 2 plus 5 times 7. 5 times 7 plus 15 times 9. 15 times 9 plus 5 times 20, and finally 10 times 80. Okay, this will equal to $520. This means the starting solution for the shipping cost, that is to minimize the transportation costs from source to destination, is equal to $520. We multiply each quantity here, which is 5 is the quantity, by the associated cost, which is equal to 10. So the 5 ton, for example, will be shipped by 100 or 100 cost. So we multiply 5 by 10. Then the value 10 refer to the quantity to be shipped, and the cost for shipping this 10 quantity is equal to $2 or $200, whatever. So we multiply 10 by 2, and multiplying 5 by 7, multiplying 15 by 9, multiplying 10 by 20, and finally multiplying 10 by 18, and adding all up, we get the starting solution by using north corner. Okay, this is for the northwest corner. Now we will solve the same transportation model and the transportation problems that we have by using the least cost method. The least cost method finds the better starting solution by using and concentrating on the cheapest routes. This method starts by assigning as much as possible the cell with smallest unit cost. Again, we are interested in the beginning with the least cost and least shipping cost from source to destination. So we will start with the smallest unit cost. Next, we will specify the rows in the column crossed out and amount of supply and demand as the same as for the northwest corner method. And then we can cross out from one cell to another by the diagonals and maybe forward pass or backward pass. It's no problem. Neither the northwest corner we only move forward or downward and we can't move diagonal. Here it's no problem to go across diagonals or go backward, but you starting and uh, all the time seeking for the least cost and the cheapest unit. Here we have the values again in this table. Inside each cell, the costs for shipping from source to destination, and we have a demand quantities and amounts 5, 15, 15, and 15, and we have supply amounts which are 15, 25, and 10. Now let's begin by using the least cost method. From its name, least cost, we seek for the cheapest cost for shipping the values from source to destination. Here, if you look at the table and the costs inside the cells, you find that the least cost here in the cell, which is 2. So we will begin with this cost. The associated demand and supply for this cost is equal here 15 and 15. So we will take here the value 15, we take the value which is less or the less quantity to be shipped, but we have 15 in the supply and demand, so with the same value we have 15, and subtracting from this will equal to 0 and subtracting from this equal to 0. Now this source is or this destination is already plugged because we haven't any more amount to be shipped, but we can again this may be plugged for the supply, but we can plug the two at the same time in one step, supply and demand our source and destination. So we will block this for the first step and go in the next step to the least cost for the remaining costs or the remaining cells. We have the remaining cells 10, 12, 4, 20, 9, 16, 11, 20, and 18. The least cost for this, of course, is 4. So we will move towards this cell. And this cell is associated with a demand 5 and a supply 10. And we will take the least quantity. So we have here 5 to be 0 value or 0 quantity. And here subtracting 5 from 10, we have 5. And note that we have crossed the value from the cell which have 2 cost amount to the cells that have 4 cost amount because we seek always for the values with the least cost of shipping from source to destination. Now this column is plugged because we haven't any more amount to be shipped, and we will look at the cells and the costs of shipping for the rest of the cells. We find that the least cost for these 6 cells is 9. So we will get the value or the quantities in this cell. This cell is associated with 15 in the demand and 25 in the supply, and we will take the least value, which is 15, and subtracting here to be 0 and subtracting here to be 10. And this column is now plugged and we haven't any more quantities to be shipped. So we have only 3 cells left. and we start again with the least cost from these three cells. Here, this cells, of course, 11 is the least value, so we have an associated value 0 and 15. We will take 0 as the least value, and here subtracting 0 from 15 is equal to 15. Now we have only two cells, 18 and 20. We will go to the least value. Okay, before here we come here and then go to this and then go to this, and now go from 11 to 18. Go to 18, which is associated with 5 in the supply and 15 in the demand. So we will take the least value, which is 5, and subtracting it from the supply values equal to 0, subtracting it from the demand quantities is equal to 10, and finally we have only one cell, and we will go to the cell of 20 and take the value which equal to 10 in the demand and 10 in the supply equal to 10. Subtracting here from 0 and subtracting here equal to 0, because it's a balanced model, all the supply amounts should in the end of the solution equal to 0 and all the demand equal to 0, because the transportation model here is a balanced model. Now let's count the basic cells. The basic cells again, that's the cells that has values inside it, and that we depend it in the calculations of Z as the starting solution. Let's count now. Equal to 1, 2, 3, 4, 5, and 6. However, 0 is a value, but no problem. It's a basic cell because it have an amount on it. Okay, let's now move to the last step in this method, which is calculating the starting solution for this problem by using least cost method. As we do in the northwest corner method, we will multiplying each cost by its associated quantity and shipped. Okay, multiplying 2 times 15, 4 times 5, 9 times 9, 9 times 15, 11 times 0, 20 times 10, and finally 18 times 5. And adding them all up to get the values for the starting solution. Let's calculate it again. Equal to Z in this case by using the starting solution least cost method equal to 2, 15, which is the quantity, times 2, which is the cost, plus 0 times 11, plus 15 times 9, plus 10 times 20, plus 5 times 4, plus 5 times 11, 18, which is equal to 475. Now this means the starting cost or the starting solution for this problem by using the least cost method is equal to $475. Note that the value of the starting solution by using least cost method is less than the value by using northwest method. So this means that using the least cost method is more better than using the northwest corner method. But the northwest corner method is more easier because the path is forward and no diagonals, and the calculations is more easier. Now again, here in the least cost method, we move from cell to another by seeking for the least cost, and we can move in a diagonals and we can go backwards. It's no problem, but be sure from your calculations. Now we covered only two methods for the starting solution, and in the next video we will take the verbal approximation method and getting the optimum solution by using the method of multiplier. Please study hard for this part and use the exercises and solve the example in your reference to be more practice in this topic. Thank you.